This video, we're going to talk about bonding and some of the things that go into that. And I want to start off with a couple of terms. So what we're going to be talking about with bonding is typically intramolecular attraction. And that is different from an intermolecular attraction. Okay, so if you remember last year, we talked about attractions. And this is typically, if I have something like water molecules, so let's say I go to so inter means between something. So if you go to interstate, the interstate goes from one state to another, and it's between states. If I have a water molecule, let's say for instance, oxygen and hydrogen, and this is my water, and I have another water molecule. Okay, so oxygen, hydrogen, and this here, between the molecules, this is my attraction. So what we're going to call this is an intermolecular attraction or a force. Okay, it's also called intermolecular force. A lot of times it's abbreviated IMF, intermolecular force. That's between the molecules. Intra means within the molecule. So if I have something that is, let's say my water molecule again, and I'm going to draw a little further apart from it now because I want to show you what I'm talking about. So typically there's not really any space, but here, within the molecule, this whole thing is the water molecule. This thing here is what we call a bond. And we learned about bonds last year. We learned about how electrons are, this perfect balance. Remember the balancing of attractions and repulsions. And so there's forces involved there. And with that perfect balance of attractions and repulsions, that is, with the electrons here, that is a bond. That's an intramolecular force or bond. Okay, so that's within the molecule. This is actually called a covalent bond because it's between valence electrons. So we learned about this also last year. This is sharing the valence electrons, and that's my intramolecular bond. Intramolecular can also mean an ionic bond. So ionic bonds are also considered intramolecular. It's kind of a weird term because a molecule, you kind of have to have a molecule to be intramolecular. Molecules are all nonmetals. Ionic things are not molecules, so it's kind of a weird term, but intramolecular is just a bond. Ionic things, metallic things, we'll talk about a little bit too. So I just want to give you, within is intra, between, that's between the molecules here, okay? So we're going to spend time talking about ionic bonding today. Ionic bonding, let me just give you a definition. So ionic bond is a special kind of bond. It's an attraction between oppositely charged ions in a chemical compound. And typically it's between a metal and a non-metal. So for instance, one very common substance is sodium chloride, NaCl. NaCl is an ionic substance because this is a metal, and this is a nonmetal. And what happens, as we should know, is sodium, Na, is in the first column of the periodic table. You can see sodium is right here. So sodium has one valence electron, and remember, the sodium loses one electron, and it becomes a positive charge. Chlorine, because sodium likes to lose that electron, it doesn't have a very strong core charge. It's got a very weak core charge, whereas chlorine here is in the 7th column. So it's further to the right on the periodic table. It's got a very strong nucleus, a nuclear charge. It wants to hang on to those electrons and actually wants to pull in electrons. So chlorine, Cl, it will pull in or gain one electron because everything wants to either gain to get to 8 or lose, so it loses all of them. So loses, this one loses, this one gains, it gains an electron, becomes a negative charge, and then these two ions then connect together, and that is my ionic bond. So I'm not sharing electrons here, I just have a charge, plus charge and a minus charge, and this attraction here forms this bond. Okay, so that's what ionic bonding is. It can also be, it doesn't have to be a metal. This ion here can sometimes be something like NH4Cl. Sorry, so NH4 has a positive charge, and these are all nonmetals, and so this could be this does not have to be a metal all the time. It could be NH4, and you can have Cl minus, and they can come together and form an ionic bond here. So my plus and minus come together, they bond together like that. So, ionic bonding. And this brings us to something called the bonding continuum. So bonding is kind of a strange thing because on one end of it, we have, let's say I have ionic character. And on this side, I have things like sodium chloride, lithium fluoride, or things like that are metals and nonmetals. Ionic character means that it is really pulling those electrons away. So I have very ionic things on this side, but then on the other side of the spectrum, this continuum, is, so this ionic things is pulling electrons and not sharing at all. Okay, so some things that really, really, really pull electrons and they don't share is very ionic. And then something that does not, so for instance, okay, so with this bonding continuum, let me just show you a all covalent substance. So if I have something like nitrogen, N2. Nitrogen is something we breathe in the air. It's got a nitrogen here and a nitrogen here. And remember, if I have this, it's this electron cloud, right? So this electron cloud for nitrogen and nitrogen, it's sharing electrons here. Well, these are both the same element. So they share evenly. And because they share evenly, it's very covalent. There's no pulling of electrons. There's no one element that's pulling more stronger than the other. So this is very covalent, whereas something on this side is ionic. So it's this continuum, and there's a really kind of fuzzy area where some things in the middle here, for instance, if I have something like HCl is these are both nonmetals, and chlorine might pull the electrons a little bit more than hydrogen, so they might pull this direction a little bit. So it's covalent, sort of, but it's also kind of ionic, and it might be in between these things. So there's not really any clear-cut covalent or clear-cut ionic, you have to kind of look at the elements and see what you have. And so one way to figure out the character of something is if it's ionic or covalent is the electronegativity values. So electronegativity, remember, is the ability to attract bonding electrons. So electronegativity is the ability to attract bonding electrons. If it's a very high electronegativity, like fluorine is the highest one, that's around 4, that's going to pull electrons a lot. If it's very low, like francium here, that's not going to pull a lot, and it's just actually going to give away electrons. And you can actually look at these numbers. So K, so if I have K and Cl, for instance, K has an electronegativity of 0.82. And Cl has an electronegativity of 3.16. So this difference here, if I just take a calculator or if I just subtract these two numbers, and so 3.16 minus 0.82 is 2.34. That's a pretty big difference. If I take something like K and F, so 0.82 and 3.98, subtract those two things, 3.98 minus 0.82. This is even a bigger number, 3.16. So if this number is really big, it's got more ionic character. So more ionic character. This one here, it's still ionic, but it's not as much ionic character because it's not pulling the electrons as much. So this one is really going to pull electrons a lot. The cutoff, we go back to the continuum, it's around, if you look at this thing here, if the difference is around 2.1, so if you take those numbers and subtract, and if anything that's bigger than, if this is 2.1 and bigger, I should have drawn this other way, but this is like a difference of 0 here. And if I go all covalent, so this has a difference of 0. This one here has a difference of 2.1. And then if I have really high difference, then it's really, really big number. So that's a big difference, okay?